To effectively communicate code requirements, especially when there are language barriers, several strategies can be employed. Firstly, consider visual aids. Creating simple diagrams or flowcharts can illustrate code requirements in a readily understandable format. The use of color-coded or highlighted sections can emphasize important points, drawing attention to critical aspects of the code. Incorporating visual cues, such as icons or arrows, can further guide comprehension, making the information more accessible. Secondly, utilize simplified language. Break down complex concepts into smaller, more manageable chunks. Use plain English and avoid jargon or technical terms that might be confusing. Present the information in a narrative style that is easy to follow, almost like telling a story. This approach makes the technical information more approachable and less intimidating. Thirdly, implement interactive exercises. Engage individuals in hands-on exercises where they can apply the code requirements directly. Provide relevant examples and encourage questions to foster a deeper understanding. Use interactive simulations or quizzes to reinforce learning and assess comprehension. Practical application solidifies the concepts in a more effective way. Fourthly, employ storytelling. Explain the rationale behind the code requirements by telling stories or providing real-life examples. This approach makes the requirements more relatable and less abstract. Highlight the potential consequences of not following the code and the benefits of adhering to it. Illustrating the real-world impact can reinforce the importance of compliance. Fifthly, adopt a collaborative approach. Encourage working with colleagues to review and discuss the code requirements. Provide regular feedback and support to assess progress. This collaborative environment promotes shared learning and understanding. Additional tips include pacing communication, repeating key points, encouraging note-taking, providing written summaries, and being patient and understanding. Language barriers can take time to overcome, so consistent effort and support are essential. When explaining electrical concepts, it's important to use clear and precise terminology. For instance, when discussing voltage, amperage, resistance, and power, it's helpful to provide practical examples related to common electrical systems. When discussing voltage, explain how different voltage levels are used in various applications. For example, in residential settings, 120 volts is commonly used for lighting in small appliances, while 240 volts is used for larger appliances like ovens and dryers. In commercial and industrial settings, higher voltages such as 208 volts, 277 volts, and 480 volts are often used for powering equipment and machinery. Providing specific examples helps to illustrate the practical application of voltage in different contexts. When discussing amperage, explain how it relates to the current flowing through a circuit and the size of the conductors. For example, a 15-amp circuit is typically used for general lighting and receptacle outlets, while a 20-amp circuit is used for kitchen appliances. When dealing with larger loads, such as motors or 8-track systems, higher amperage circuits may be required. Understanding the amperage requirements of different devices and equipment is essential for proper circuit design and safety. When discussing resistance, explain how it opposes the flow of current in a circuit and how it affects the voltage drop. For example, a high resistance connection can cause excessive heat and voltage drop, leading to equipment malfunction or fire hazards. Understanding the concept of resistance is crucial for troubleshooting electrical problems and ensuring the integrity of electrical systems. When discussing power, explain how it is calculated using voltage and current, and how it relates to the energy consumption of electrical devices. For example, a 100-watt light bulb consumes 100 watts of power, while a 1500-watt space heater consumes 1500 watts of power. Understanding the power requirements of different devices and equipment is essential for determining the appropriate size of circuits and electrical panels. When referencing the National Electrical Code, it's helpful to provide specific examples of code requirements related to wiring methods, overcurrent protection, grounding, and equipment installation. For example, National Electrical Code Section 310.15 provides guidelines for determining the ampacity of conductors based on their size, insulation type, and insulation conditions. National Electrical Code Section 240.4 provides requirements for overcurrent protection, such as circuit breakers and fuses to protect conductors and equipment from overloads and short circuits. National Electrical Code Section 250.4 provides requirements for grounding electrical systems to minimize the risk of electric shock and ensure the proper operation of protective devices. National Electrical Code Section 430.52 provides requirements for motor circuit protection, including short circuit and ground fault protection, to protect motors from damage due to electrical faults. Providing specific examples of National Electrical Code requirements helps to illustrate the practical application of the code and promote compliance. When explaining the importance of safety in electrical work, emphasize the potential hazards associated with electricity, such as electric shock, arc flash, and fire hazards. Explain the importance of following safety procedures, such as wearing personal protective equipment, energizing circuits before working on them, and using properly insulated tools. Encourage individuals to seek professional training and certification to develop the knowledge and skills necessary to work safely with electricity. Regular safety audits and inspections can help to identify potential hazards and ensure that safety procedures are being followed. Providing ongoing training and education can help to reinforce safety practices and promote a culture of safety in the workplace. When addressing specific questions or concerns related to electrical work, it's important to provide clear and concise answers that are easy to understand. Avoid using technical jargon or complex terminology that may be confusing. Use visual aids, such as diagrams and illustrations, to help explain complex concepts. Provide real-world examples to illustrate the practical application of the concepts. Encourage questions and provide prompt and thorough answers to address any concerns. By providing clear, concise, and informative explanations, you can help individuals develop a better understanding of electrical concepts and promote safe work practices. Remember to emphasize the importance of ongoing learning and professional development to stay up to date with the latest codes, standards, and technologies. The electrical field is constantly evolving, and it's essential to stay informed to ensure the safety and reliability of electrical systems. When explaining the concepts of electrical circuits, it is beneficial to start with the basic components and their functions. Firstly, you have the voltage source, which provides the electrical potential difference that drives the current flow. Secondly, the conductors, typically wires, provide a path for the current to flow from the source to the load and back. Thirdly, the load is the device or component that consumes electrical energy, such as a light bulb, motor, or appliance. Fourthly, the switch is used to open or close the circuit, allowing or preventing current flow. These components form the basic closed-loop circuit. To explain series and parallel circuits, start with series circuits. In a series circuit, components are connected end to end, forming a single path for current flow. The current is the same through all components in a series circuit, while the voltage is divided among the components. If one component in a series circuit fails, the entire circuit is interrupted. Next, discuss parallel circuits. In a parallel circuit, components are connected side by side, providing multiple paths for current flow. The voltage is the same across all components in a parallel circuit, while the current is divided among the components. If one component in a parallel circuit fails, the other components continue to operate. Explain the difference between alternating current and direct current. Direct current, or DC, flows in one direction only. Examples include batteries and electronic devices. Alternating current, or AC, periodically reverses direction. It is the standard form of electricity used in homes and businesses. The frequency of AC is measured in hertz, which indicates the number of cycles per second. In the United States, the standard frequency is 60 Hz. Explain how transformers work to step up or step down voltage levels. Transformers consist of two or more coils of wire wound around a common core. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil determines the voltage transformation ratio. Step-up transformers increase voltage, while step-down transformers decrease voltage. Transformers are used to efficiently transmit electrical power over long distances and to provide appropriate voltage levels for various applications. When teaching about grounding and bonding, it's important to stress their importance for safety and proper operation of electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices to trip and clear the fault. Bonding ensures that all metal parts of an electrical system are electrically connected, minimizing the risk of electric shock. Explain the difference between grounding and bonding conductors. Grounding conductors connect the electrical system to earth, while bonding conductors connect metal parts together. The grounding electrode system typically consists of a ground rod, ground plate, or metal water pipe that is in direct contact with the earth. Explain the purpose of overcurrent protection devices, such as circuit breakers and fuses. Overcurrent protection devices are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds a predetermined level. Fuses are one-time devices that melt and break the circuit when the current exceeds a predetermined level. When explaining the types of wiring methods, it's important to cover the commonly used wiring methods and their applications. Firstly, non-metallic sheet cable, also known as Romex, is commonly used for residential wiring. It consists of insulated conductors enclosed in a plastic jacket. Secondly, electrical metallic tubing, or EMT, is a thin-walled steel conduit used for protecting conductors in exposed or concealed locations. Thirdly, rigid metal conduit, or RMC, is a thick-walled steel conduit used for protecting conductors in harsh environments. Fourthly, flexible metal conduit, or FMC, is a flexible metal conduit used for connecting equipment that may be subject to vibration or movement. These wiring methods are selected based on the specific application and environmental conditions. When discussing how to read electrical diagrams, it's helpful to familiarize them with the common symbols used in electrical diagrams. Firstly, resistors are represented by a zigzag line. Secondly, capacitors are represented by two parallel lines. Thirdly, inductors are represented by a coil symbol. Fourthly, switches are represented by a line with a break. Fifthly, transformers are represented by two coils with lines connecting them. These symbols are used to represent electrical components in diagrams. Explain how to interpret single-line diagrams and schematic diagrams. Single-line diagrams show the main components of an electrical system and their connections, while schematic diagrams show the detailed wiring connections between components. By understanding the symbols and conventions used in electrical diagrams, individuals can effectively troubleshoot and maintain electrical systems. When teaching about electrical safety, it's important to emphasize the potential hazards associated with electricity and the precautions that should be taken to prevent accidents. Firstly, always to energize circuits before working on them. Secondly, use properly insulated tools and equipment. Thirdly, wear personal protective equipment, such as safety glasses and gloves. Fourthly, avoid working in wet or damp conditions. Fifthly, follow lockout/tag-up procedures to ensure that circuits are not accidentally energized while being worked on. These safety precautions can help to prevent electric shock, arc flash, and other electrical hazards. When explaining how to use a multimeter, it's helpful to demonstrate how to measure voltage, current, and resistance. Firstly, to measure voltage, connect the multimeter in parallel with the circuit. Secondly, to measure current, connect the multimeter in series with the circuit. Thirdly, to measure resistance, disconnect the circuit from the power source and connect the multimeter across the component. Be sure to select the appropriate range and function on the multimeter before taking measurements. When teaching about troubleshooting electrical circuits, it's important to cover the common problems and the steps involved in diagnosing and repairing them. Firstly, check for tripped circuit breakers or blown fuses. Secondly, check for loose connections or damaged wiring. Thirdly, use a multimeter to measure voltage, current, and resistance to identify faulty components. Fourthly, follow a systematic approach to isolate the problem and repair it safely. By following these steps, individuals can effectively troubleshoot and repair electrical circuits. When explaining the importance of following the National Electrical Code, it's essential to emphasize that the National Electrical Code is a set of standards and guidelines for the safe installation and maintenance of electrical systems. The National Electrical Code is developed and updated by the National Fire Protection Association, and it is widely adopted by state and local jurisdictions. Following the National Electrical Code helps to ensure the safety of people and property, and it is essential for compliance with legal and regulatory requirements.